convergence tests, the first convergence test is to take the limit of the sequence as n goes to infinity. That has to equal 0. If it's not 0, then the series diverges. That's the first one. The second one I look for is a geometric series because I can find the value. Absolute value of r must be less than 1. The third one, at least temporarily, are the collapsing sums. And then we're going to have some other ones, and they relate to the integral. So there's an integral test, and there's also a p-series test. So why are we jumping back to 510? Because we normally would have done it. So we would have been okay for doing this in Chapter 8, but we haven't done it. So these are BC topics. You will see improper integrals on the exam. It is important to write the correct notation. Okay? If it's a free response question and you do not use the correct notation, you will not get full points. Some of you are going to be really lazy and not want to use the notation. And so we'll see what happens. We'll work with it on that. We have to review some old things. Possibly convergence. Possibly. Then you have to use one of these other ones. Now, if it's not 0, you're done. So that makes the homework easy. So first take the limit of the sequence, always the first thing you do. And if that limit is not 0, it's divergent, you're done. Right. It's not 0. Divergent. So this is all we know. We have 10 in all. So we have a couple of quick ones coming up. One is the integral test. Well, to do the integral test, we have to be able to integrate improper integrals. So first, let's remember this. This comes from the fundamental theorem of calculus. What is the integral from a to b of f of x dx? Do you remember how to do that? You find the antiderivative and evaluate it at the endpoint. Well, I would hope you remember it's the fundamental theorem. Okay, where f of x, capital F of x, is any antiderivative. Okay, so I have to remind you about that. Right. Those are the first 3 convergence tests. And they should be in your packet. Page numbers will be wrong, unfortunately. Sorry. So what about the integral from a to b of x to the n? What's the antiderivative of x to the n? Right, x to the n plus 1 over n plus 1. Evaluated at a and b. So this would be equal to, you see in the back? That would be equal to what? What's the x? X is b. So it's b to the n plus 1 over n plus 1 minus a to the n plus 1 over n plus 1. Okay, that's the fundamental theorem of calculus. Are you ready? We should remember that from last year. Now, you may have to do some use substitutions to do your integrals. And there's one we have to throw out, and I've got to look that up. It has an integration by parts. We'll do it later when we do this chapter. Okay, here's an improper integral. We have 2 kinds. We are only doing type 1 today. Ori? Sorry to interrupt you. Okay, so if you haven't done integrals, Trevor, you're going to have to find antiderivatives. And if you take that orange sheet that I gave you, those are the only ones we know. You have to do use substitutions to transform them into those things. Okay, ready? Okay. I've talked about, okay, girls, talked about improper integrals. I haven't really talked about what they are. They're improper because we are going to integrate this function from a fixed value off to infinity. So how do we write that? That's going to be what's critical. And this is why I say you have to write it correctly. The integral from a to infinity of f of x dx. If this is free response, would need to be rewritten. We will integrate from a to some value, we'll call it t, of f of x dx. And then we will let the limit as t goes to infinity is equivalent. Now, when you get to your homework, you're not going to want to write it out, but really you should get in the habit of writing it. The integral from a to infinity is, so I'm going to put a t value out here and integrate from a to t. And then I'm going to take t and make t go to infinity. So I take a limit. Now, do you think that, remember what an integral is, it's an area under the curve. Do you think that the area under the curve will converge? Sometimes it does, sometimes it doesn't. So this is going to be a test that we can do, Kate, Grant, on our series. We can, if we can integrate the function and find if the integral converges or diverges, then I know if the series converges or diverges. Unfortunately, when you get to factorials, we can't integrate them. We have to have another way to deal with factorials. It's a great test provided you can integrate, you can find a function you can integrate that goes with that series. So let's do a problem. And I wrote it out right here. So let's do this one. This is 1 over x. What series does that make you think of? It makes you think of the harmonic. And we know that the harmonic series does not converge. Right? Now, tomorrow's going to be a tough day because I'm going to do the integral test and I'll explain it tomorrow. Well, no, you can do the integral test, but understanding it is a different matter. But you can do it without a problem. Okay, so we are going to take this, and I'm going to write it again, integrate from 1 to infinity of 1 over x dx. Well, I'm going to integrate then. I'm going to take that from 1 to some t value, and then let t go to infinity. That's how you write it out correctly. Okay, I'm just rewriting it. Okay, let's find the integral. Well, I have the limit as t goes to infinity, and you're going to integrate 1 over x. Do you remember that one? The natural log of x. Now, remember, it's the absolute value. Do I really need the absolute value? My values are positive. Do I need absolute values? No, not really. But I'll put it in there. Now, you're not going to like this problem, so it takes a little bit more to write out. So it's the log of t minus the log of 1. Not if you don't need it, no. And since we don't need it. The problem is when you get the free response problems on the exam, you might need it. And I've seen that happen, so I don't want you to miss it. Okay, so let's take the limit. What's true about the log of t as t goes to infinity? It's infinity. Now, for this limit to exist, they both must exist. This does not exist, and this is minus 0. The log function, even though it doesn't grow very quickly, does go off to infinity. Okay, on your integral test, guys, Matt, on your integral test, since 1 over x doesn't converge, guess what? The harmonic series doesn't converge. Whatever the integral does, the series does, provided you can integrate it. But if it's 1 over x n factorial, I can't integrate that. I don't know how to. That's the problem. If the integral of the function converges, then the series will converge. If the integral of the function diverges, then the series diverges. This will be a convergence test, so we have to remember how to integrate. Right, and we need some practice doing improper integrals. And it's a BC topic on the exam. No. Will the series converge to the same number? No, because this is the area from 1 to infinity, whereas the series, it's just, you're talking about those discrete points. You don't have all that area. I did. Should we try 1 over x squared? Well, it's kind of what I'm going to lead to. Pardon? No, because those are just dots. Let's do this one. Okay, Eric? Let's integrate from 1 to infinity 1 over x squared, because I've told you that the summation of 1 over n squared converges. Well, this is kind of leading into the last example. Okay, ready? Okay, guys. Now I'm going to have to rewrite this. This is equal to from 1 to t, and it's the limit as t goes to infinity. And I don't know how to integrate that. It's not the log of x squared. The log is 1 over x. No use substitution. X to the negative 2. Because all you have, you take that orange sheet out, you write down your integrals, that's all you have, and this is the power rule. Log of x squared is not going to work. You have to transform them to look like anything on that orange sheet. But that does. It's the power rule. Then we're going to do the hard one next. Okay, guys, what's the antiderivative of that one? Over negative 1, integrating from 1 to t. All I'm looking for is to see if it converges. You're going to find a value here. So it's the limit as t goes to infinity. It's the power rule. So this is negative 1 over t. Do you guys agree with that? I put the t in there. That's negative. Then it's minus a negative, it's a 1 to the negative 1 over negative 1. Well, I just put the 1 in there. It's 1 to the negative 1, which is just 1, over negative 1. So I'll rewrite it. I didn't want to do it too fast. I just substituted it in. So it's negative 1 over t, and this is going to be 2 negatives make a positive plus 1. Now, what happens to 1 over t as t goes to infinity? 0. 1 divided by infinity is 0. So what's this limit equal to? 1. Since this converges, we know that the series associated with that function, which is 1 over n squared, must also converge. That's just an intro to the integral test. All we're going to do in this assignment is work on integrating these and doing improper integrals. But that's just a preview for tomorrow. Okay? What's 1 over t? Why would it be 2? Remember, this integral and the series don't converge to the same thing necessarily. Plus, this started at 1. The other one started at n equal to 0. If you think about it. Okay, it started further over. Doesn't matter. Just has to converge. No, I'll get some more. Okay, let's do this one. Bet you forgot this one. Now, this is an improper integral. You guys, do you know what this looks like? Well, you do, but you might not realize it. Hey, guys, what happens when x is 0? Y is 1. And what happens when x gets to be really large? 0. It's going to go to 0. So it's going to kind of look like this. On the other side, because it's even, remember even odd? It's also will look like this. Okay, so it's an improper integral because this is going to go off to infinity. So does it converge or doesn't it? I don't know. So we have to break this into 2 problems. you have to integrate from negative infinity to any value, let's call it 0. Well, because they're the same, but any value, you can do it a if you want, plus, and then I'm going to integrate from 0 to positive infinity. And you know what? The areas are the same, aren't they? So why not just do one of these and double it? Because it's the same, right? Assuming it converges. I don't know. I don't remember. Very true. Okay, so let's do that one because I'd rather work with positive numbers than negatives. Don't you agree? Okay, so we will integrate from 0 to t, and this is the limit as t goes to infinity of 1 plus 1 plus x, 1 over 1 plus x squared. Do you guys remember that antiderivative? Close. Not negative tangent. Not tangent. Inverse tangent. And remember when we did some of these problems? Do you remember doing some of those in your homework? Oh, sorry, that should be t. My mistake. Okay. Sorry, this should have been an x. All right. And you know what? They don't get particular on the exam either if you mess that up. So it's the limit as t goes to infinity of inverse tangent of t minus the inverse tangent of 0. Now, if you don't remember the inverse tangent is 0, I prefer to work with the tangent function. Some may prefer the inverse tangent. I'm going to do, I'll do both because it's your preference. It doesn't matter to me. So here's my tangent. Where are these asymptotes? Guys, pi over 2, negative pi over 2. And to do the inverse, what's going to happen? They will become horizontal asymptotes. So I don't care which way you think about this. You can think about it either way. And then this is going to look like this. Whoops. Not exactly right. Let me undo that. There we go. Something like that. Okay, what's the inverse tangent of 0? That's easy. It's 0. Now, as t goes to infinity, what is the inverse tangent going to? Pi over 2. Otherwise, I could think of it in a different way, because that's the way I think of it, because I don't have any problems drawing the inverse tangent function. And that one I'm okay with, but the sine and cosine can be a little trickier. This really is the limit as t goes to infinity, and I'm going to rewrite this. The tangent of my angle is equal to t, because I prefer to think of inverse tangents as angles. So the tangent of what angle is going to positive infinity? Pi over 2. It doesn't matter. There it is. I don't care. But what's the limit then? So what's this limiting value? Pi over 2. How many of these do we have? Because they're both identical. We have 2. So this ends up being equal to 2 times pi over 2. So it's just equal to pi. Because these are the same. Because f of minus x equals f of x. And do you remember how we changed those? If they're even functions, we could go double the integral from 0 to infinity of f of x. It's even. They're both the same. If you want to integrate it, you can. You may do so. I'm lazy. Okay, so you're going to have some troubles with some u substitutions. And if you, yeah, well, we'll see. You're rusty. Okay. this is the last example. The rest of the time is for you guys to work. Um, you will. Now, you guys, we did part of this. Okay, guys? There. This is important. Okay, guys? That's important improper integral. Guys, I already did p equal to 1. That was the integral from 1 to infinity of 1 over x. And we said that ended up being the log function, and we said that diverged. I did that earlier today. Yes, I did. P is going to be a number. When does it converge? There's 1 over x. X is raised to what power? 1. What happened when x was raised to the second power? It converged. So the question is, when does this converge? So at p equal 1, it diverges. What if p is equal? No, that was the log. Remember, this is the log of x. This is the log of infinity. That diverges. Go back and look at it. When p is equal to 2, this converged. What if p is equal to 0? You have to consider all cases. If p is 0, then that's the integral of 1 dx from 1 to infinity. That's the area under the curve of y equals 1 from 1 to infinity. Does that converge, or does that keep getting bigger? Okay, so this diverges. Where do you think the dividing point is? What if p is negative? Let's let p be negative 1, because you'll see what happens. If p is equal to a negative 1, then I'm integrating from 1 to infinity 1 over x to the negative 1, which is the integral from 1 to infinity of x dx. Well, we know what that looks like. That looks like this. What's true about that area? It's getting bigger. Okay, so if p is less than 0 or smaller, it's certainly not going to converge. Where do you think the dividing point is? 1. That's right. So put this in your notes. And if you think about it, like if you try p is equal to 1/2, and I'm going to integrate 1 over x to the 1/2, I'll let you work that out to show you that that diverges. Okay? So this one converges, Grant, for p greater than 1, called the p series. And we will use this as another one of our convergence tests. Come on in. There's a picture of my chihuahuas. You can't see them. Put that in. That's a big test. One of the biggest tests you're going to run into. Put that in. Okay? If p is greater than 1, this converges. If p is less than 1, it diverges. Okay? And that's it. Now you have some time to work. And I can show you one of the ones you might want to actually do. But let me stop this.